what I want everybody to do, you guys can stay where you're at. I want everybody to be able to see this, because I want to know what you think is going to happen when I take and fill a cup up with this liquid or water and then pour salt into it. Okay, so we're going to get some. So I want y'all to come on up here. If you can see, you can see. No. Okay, this is what I can't have you. Don't touch the table. You have to lean back. Stay back. Stay back. Stay back. I should have probably front-loaded that a little bit more. Do not touch the table. And I need Maddie? Right? Can you come here, Maddie?
Hey, Max.
Come back here.
Max, you can stay in your seat.
Put your hands down.
Just sit.
Put your hands, yeah, Max, stay right there. So what do you think's going to happen if I fill this cup full of water and then add salt to it?
I'm going to explode.
It won't explode. I wish, but it's not that cool. So we have it'll dissolve, okay? It'll dissolve. Hannah. Wait a second. I want hands.
Dissolve, but then if it's heated back up again, then the water will evaporate and then the salt will be there.
Okay, so perfect. Carbonated water. I've never heard that one, but that's good. That's good.
It becomes
Salt water. Okay, salt water. Yeah.
It becomes a compound.
Okay, becomes a but is it water already a compound?
Yeah.
Okay, that's fine, but it'll become another compound.
By the other end.
So when I fill the water, so what I'm going to have you do, I'm going to fill a cup full of water. Now, what did we say earlier? We said that what? We said that what? Matter takes up space, and two substances, what? No, two substances cannot occupy the same space. This is matter. This is matter. They cannot occupy the same space, right? We all agree with that?
Yeah.
Yes, sir.
There will be two different layers.
Oh, two different layers. So I'm going to fill this up, and then Maddie, what I'm going to have you do? Don't touch the table. Now, let me ask you this. Why would I put a towel under the cup if you don't think anything's going to happen?
It might spill.
It might spill?
Be careful.
Is that all? Let's just check. Don't touch the table. Is that filled to the top?
Yeah.
No.
Is there any additional space in that cup? Oh, there is. Okay. Well, let's just to make sure, let's just put... Is there any more space in that cup?
No.
Okay, Maddie, what I would like you to do is I would like you to slowly, hold on. I need everybody's attention. I need you to fill this, or slowly pour as much salt as you can in the water. Wait a second. What did you say, Maverick? What will happen?
Since there's more mass into it, the water will leak.
So you think the water will leak over because there's more mass in it? Josh, what do you think's going to happen?
If you put so much salt in it, that exact amount of salt, the water will pour out. Yeah.
So however much salt we put in, we think the same amount of water will pour out.
Yeah. I think it'll dissolve before the water can overflow.
Okay, dissolve before the water can overflow. Okay, Thomas.
You know how you open sodas?
Yeah? You think that's what's going to happen?
I hope.
Are you ready for this? Do you need like a cover or something? No, you're good. Okay, pour a little bit of salt in there. Slowly, just pour it in slowly. Pour it in more. Keep slowly, slowly.
It's snowing.
Slowly. Wait a second. Oh, don't bump the table, I said.
Max. That wasn't me. It was snowing.
Keep going.
it's a dome. It's leaking.
What? Okay, let's see. Stop right there.
It's leaking.
How much salt is in there right now? Let the fog clear.
Oh, I can see.
Don't touch the table. So what do you notice with this cup of water right now? Yes.
The water, it kind of has like volume, like nothing's. It has like volume and like nothing's like. Not like.
It's like just sitting there.
It's kind of like taking its own form.
Okay.
It's
Look.
like the matter, the air is making it stay there.
Okay. Okay.
It's like,
Let's see. Can I see this real quick? Let's see. Can we add more salt, maybe?
Yeah.
Add more salt. Let's see.
The whole thing.
see where we can go with this. Don't move the table. Okay, stop right there. I think we just hit. But so how much salt do we have? Do we have the same amount of salt at the bottom of the cup that of water that's overflown?
No.
I just saw one drip of water overflow. And we've got about, how much, Thomas, Jack, what do y'all guys think? How much salt do we have at the bottom there? You're closest.
582,000.
No. How much salt in inches?
Like that.
2. Like an inch.
An inch, right? Maybe a quarter inch? So now let me ask you this. This right here, is that equal to the amount of salt in the bottom?
No.
So right now, are two substances occupying the same space?
No. Wait, yes. No.
Now, didn't we just say that two substances can't occupy the same space?
No, because it's
But we
all
filled,
same.
Maddie, wait a second, right here. Maddie, did we fill that cup up to the top? Did you add salt to it? Okay. So our two substances, or two pieces of matter occupying the same space right now?
Yes.
How is that? We learned that just can't happen.
The salt is just.
Well, I didn't. Hannah, no, I'm taking quiet hands.
So, when you pour the salt in, it shares the same space with the water.
Okay. What water? What are you talking about?
The liquid,
Oh, awesome. Okay.
because it dissolves, and so it doesn't become a part of the water, but it's still sharing the same space.
Okay. Who else? Sammy. Wait a second, Sammy.
It also, when the salt went in, and it sank to the bottom, and it pushed the water that was in the space where the salt was over the top.
Okay. Good. Who else? Kyra.
I think the salt is dissolving in the water because the water's starting to turn.
So,
I saw that
this is a water molecule, right? What is this
Oxygen.
element right here? Oxygen. What are these two elements? What is this?
Hydrogen.
What are these? Thomas, if you're not going to...
Two atoms.
Kyra. Hydrogen. Okay, so there are, like Hannah said, Hannah, will you hold that? There are spaces in between the molecules, right? So you have those molecules, they're connected, the hydrogen positive to a negative oxygen. And there's spaces in between there. And what's happened is the salt, I gotta be honest, I had no idea that would happen with the sand too. That's kind of cool. I only thought the salt because it's NaCl, right? So it's another compound. I thought that was just dirt. But it worked. So what's happening is the salt and the sand, I need you to listen up here. The salt and the sand are taking up the same space, which is the spaces between the water molecules. Now, really quickly, what you're noticing here, this is what we call, does anybody know what this is called?
It's like heat burst.
Heap over. Okay, this is called heap over. It's called cohesion. And what you have a couple of things going on over here. You have cohesion, which means the hydrogen bonds, let me see this. The hydrogen bonds are very difficult to break. So when hydrogen bonds with oxygen, it's very difficult to break. And what's happening is, that's why it's so hard for water to break apart, so it'll come up and raise up over the lid. You also have adhesion. The water is actually adhering to the cup, to the chemical properties of the cup. So this is a very interesting little molecule right here, okay? So Hannah and a couple of other you guys said that there's spaces, right? It dissolves. There's spaces in between the molecules. And that's what's causing this to happen. You wouldn't think that two states of matter, put your hand down, Kyra. You wouldn't think there's two states of matter that can occupy the same space, but that's exactly what's happening here. They're just occupying the spaces